building the first proof-of-concept version of a machine learning system can be pretty easy. But when you try to operationalize, what was built as the prototype is only a small piece of what you need to pay attention to. Problems show up when you try to scale out and keep a system in long-term continuous operation. And no wonder in a recent survey, Gartner reported that more than 80% of data science projects don't succeed. According to a 2021 study from Algorithmia, the average deployment time for models that make it into production is 18 months. So why is AI hard? Well, let's dig in and find out. Often, when we talk about building a machine learning application, we're talking about developing the core model. Although it is at the heart of developing a machine learning application, but when you are building, deploying, and running a machine learning application in production, it entails many other stages. To bring them into production, datasets must first be captured, stored, cleaned, and curated to extract insights and train ML models. Once trained, models need to be deployed in scalable and secure production environments. The models need to be monitored and retrained with new data to improve them. Only a small fraction of real-world ML systems are composed of the ML code, as shown by the small box in the middle. The required surrounding infrastructure is vast and complex. So the first challenge is, AI is not limited to model training. Software is deterministic or repeatable since it produces the very same output when given the same input no matter how many times it is run. Whereas in AI, the outcome of training a model can change significantly based on the changes in the underlying data. As a result, models have to be continually monitored to detect performance degradation and model staleness and will need to be retrained and remodeled often. These factors make it painfully clear that AI is hard because it depends neither on code nor on data alone, but on the combination of both. Since AI depends on a combination of code and data, many different people need to get involved to train a machine learning model and deploy it in production. Usually, a combination of software engineers, data scientists, and data engineers are involved. So getting all of these people involved and coordinating among them is a major challenge. Organizations have low collaboration between ML development and operations. AI is hard because AI requires many different roles to get involved. It becomes harder because each of these people uses different sets of tools. In software development, usually, a team standardizes on a stack, like which language, code versioning, or CI/CD system to use. In AI, different individuals prefer different machine learning frameworks, use different IDE, and most certainly don't follow common CI/CD practices. Here is a data and AI landscape from Matter. If you are a data scientist or a researcher, you look at this landscape and you get excited with the thriving ecosystem of innovation with lots of opportunities for investments and PhD thesis. However, if you're an enterprise architect responsible for making purchasing decisions or a tech lead, you probably think that this is a procurement and DevOps nightmare. You'll have to look at each one of these boxes and pick the right tool and then spend lots of time and energy stitching them together. So the tooling is really hard because AI requires integrating many different components. And to add to the problem, this space is moving at a breakneck pace. To solve these challenges of AI, the practice of ML Ops has been introduced in the last 2 or 3 years into the industry. ML Ops is about unifying both of them, the development part by the data scientist and the operations part of the machine learning engineers.